we're here at IBM Rochester, just wrapped up the IBM I Driveway to Watson event. I'm here with Charlie Guarino of Central Park Data Systems. So Charlie, tell me, what did you think of this event about Watson?
Alex, this was a 2-day workshop, and I was telling people earlier today, I feel like I was a 17-year-old wide-eyed kid again, getting back into IT, getting into computers. The excitement that I'm leaving with here today is it's over the top. What Watson can do, what I've seen it do, live demonstrations today, was amazing. The analytics, especially, they were reviewing the New York Times, the last 500 articles in the New York Times, and doing an analysis on that, and Twitter feeds. Amazing, amazing stuff. This is groundbreaking, and this is a game changer.
Thanks, Charlie. So with that, let me lead into a demonstration of how Watson can be used to recognize images relating to insurance data.
So this application started out as your typical character-based green screen application. It allows us to maintain insurance claims. It has your listing screen of records, and it allows you to go in and maintain individual data about each insurance claim. Now, in order to add Watson capabilities to this, we first modernized this application to a graphical user interface and a Node.js backend. Now, in this video, I'm not going to go over how this was done in a lot of great detail. We'll cover this in other videos. We'll just go over the high-level detail of how that's accomplished, but we'll really concentrate on what it took to implement Watson. So let's first take a look at our end results. So we started out with the screen application, and we took it to this format, where it's now a graphical application. And I'll point out just some of the nice features that you get when you do something like this. So first of all, you can see that the records are scrollable. You're not paging through the records, and that's already a nice advantage. You can also do things like click on any one of the columns and sort the records. And another nice feature that I like is the ability to filter the records. So if you're looking for something specific, you type in the words and it filters the records. Let's remove this filter and we'll go into one of these records. And you can see that, again, this is an enhanced screen. Instead of hitting function keys, and by the way, the function keys would still work, but instead of having to hit the function keys, you can use the tab panels, and you're maintaining this data in a nicer screen. There's a feature that you see that you've got photos, and you've got the ability to upload photos. So what I want you to do is watch these flags as I upload a photo. So let's just take this photo right here. And what you'll see is that automatically the checkbox is checked for motorcycle in this particular case. And if I do something similar, let's do this one. You can see now that the flat tire checkbox is checked, and so it was Watson that classified these images automatically by analyzing the image, seeing the content of the image, and then selecting the right flag. So let's look at what did it take to accomplish all of this. So first of all, we started out with code that was DDS and RPG. This is the DDS screen, so these are the screens that we were dealing with, defined as a green screen. Of course, if we look at the source, that's just DDS code. That's what it looks like. There's also RPG code that comes along with this. In this particular case, the RPG code was fixed format RPG. So this was converted into a format. So if you look at really what the process was, we took the DDS, we converted that to HTML5 and JSON, and RPG got converted into JavaScript or Node.js code. This is what the code looks like. So we're looking here at the JSON that initially represented the DDS. Now this represents the HTML5. So this is the JSON code, but this is also accessible by the visual designer. So you don't have to maintain it at this level. This is just to show you, yeah, this is what the code looks like. But the easier way to maintain it is we have the visual designer tool, and you go in here and maintain it here. This is more of a drag and drop tool where you just kind of click on things, maintain the properties over here. So that's what the interface looks like. Let's move on and look now at some of the code. Now, this right here is the Node.js generated code after the automatic conversion. And most of this code is automatically generated. You can see that it is certainly nicer than the fixed format RPG. And beyond the automatic conversion, what we've done here is we've added this classify routine. So it was first declared as a separate file that we require, and we'll take a look at what's inside of that file. And if we scroll down, you'll see that we've had to then use this classify routine, and basically we go to the part where the image is being assigned or uploaded, and we've added this code right here. And basically what is happening is that we are setting all the flags to no by default. These are the flags that represent the checkboxes that we see on the screen. And then we call the classify routine, and again we'll take a look at this classify routine in a little bit more detail. And the classify routines returns an object that has a class and a score. If the score is greater than 75%, this is the confidence level coming from Watson, then we go ahead and look at the class, and there's different classes that have been programmed in there, and based on which class it is, we're looking at the we're setting the appropriate flag. Now let's take a look at this classify claim with Watson JavaScript file, and we'll take a look at how this was built. But before we do that, I want to show you that what I had to do within Bluemix and Watson in order to get this running. So first of all, and this is obvious, but the visual recognition service had to be created, and it has to be running. So this one is up and running. I called it Insurance Claims Demo, and it's a visual recognition service that's up and running. But then I went ahead and used the Watson Visual Recognition Training tool, and at this time this tool is in beta. And what's required here is for the different types of things that we're trying to detect, you need a list of images. So I've created this right here, this insurance claims, and if I go in here inside of it, you can see that I've got a bunch of images that I've uploaded that trains Watson to recognize motorcycle accidents, flat tires, broken windshield, vandalism, and some of the things that are negative, meaning it's none of these. If you see anything that's not an accident. So in order to do this training, you're basically compiling a list of images, you're zipping those images up, and you're then dragging those zip files in here. So that had to be all set up before Watson can start recognizing. But now that we have this set up, we can write code like this. So the first part of this file is just to set everything up. So we are bringing in the Watson Developer Cloud. You're bringing the file utilities, and passing along our key. Now I've masked out the key, but you would actually get the credentials from Bluemix and Watson and put in your own key here. And then I'm also using Fibers to make this an easily callable routine. So now I have something called Visual Recognition Classify, a routine that's documented out there. And here we are calling it. So this is the classifier routine for us. We're calling it, we're passing in the ID. Again, this ID, jump back here and you can see that if I, let's go back one screen, this ID is listed right here. So I had to pass in this particular ID to Watson so that it can come back with the different classifications. So that ID is being passed, and then I'm passing in the image that's been uploaded. So I have to do this fs.create read stream and pass in the path to the image. After that happens, Watson comes back with a response, and I'm just grabbing the relevant information out of that response. So that's what this code right here is for. So basically I'm grabbing the first image that's returned. That may have multiple classifiers, but really I'm interested in the top classifier. That's the classifier with the index of 0, and we're looking then at the top class of that, and then we're returning that, and that has the score, and that has the class. Basically it comes back into here, and we can then interrogate the score and the class. So that's how this application was accomplished. And as you can see, it's really relatively speaking, not a lot of work to implement Watson visual recognition within your applications.